Yeah. In the last class we learned about the distance between 2 points where whose x coordinates and y coordinates are equal. The distance between 2 points whose y coordinates are equal is modulus of x2 minus x1, and the distance between 2 points whose y coordinates x coordinates are equal is y2 minus y1. Now let us discuss a point. Now let us discuss distance between any 2 points. Let us take A x1 comma y1 and B x2 comma y2. So for this let me draw the diagram. So this is x dash, y dash. Now this is origin here, origin. Now let us take a point A. The coordinates of A are x1 comma y1 and point B x2 comma y2. Now let me draw a perpendicular onto the axis from A onto the x-axis, and the coordinates here are x1 comma 0, and let me draw another perpendicular from B onto the x-axis, and these are x2 comma 0. Let me draw a parallel line to x-axis from A onto the perpendicular drawn there. Both intersects at a point C. As C is also a point on the perpendicular drawn here, so these 3 points will have x coordinate equal. That means this is x2 comma, as A and C on a line segment which is parallel to x-axis, then these two will have y coordinates equal. Therefore the coordinates of C are x2 comma y1. Now let me join A and B. Now as a perpendicular here, this is a right angle. Now in the last class we discussed that the distance between AC, here y coordinates are equal, so we can write the distance between AC as x2 minus x1. Now observe these 2 points. As x coordinates are equal, the distance between BC is y2 minus y1. Okay. Now by using Pythagoras theorem, we can write, we know that the Pythagoras theorem is the square of the hypotenuse is equal to the sum of the squares of other two sides. So AB square is equals to AC square plus BC square. Now AB square is equals to, we know the distance between AC, that is x2 minus x1 whole square, and the distance between BC is y2 minus y1 whole square. Now after transposing square to RHS, what we will get? AB is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square, and this is the derivation of the distance between any 2 points whose coordinates are x1 comma y1 and x2 comma y2. The distance between these 2 points is root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let us see. Once again I'm just recalling. Just let me take the point A, x1 comma y1, and the point B x2 comma y2. Let me draw the perpendicular onto the x-axis. The coordinates are x1 comma 0 and the coordinates are x2 comma 0 as and we BC and this point are on the same line parallel to y-axis, that's why we can say that these 3 points will have x coordinates equal. Therefore the abscissa of C is x2, and as AC is a line segment which is parallel to x-axis, that's why y coordinates are equal and the ordinate of C is y1. Now the distance between AC, the distance between AC, as y coordinates are equal, we need to use the formula modulus of x2 minus x1. Therefore x2 minus x1 is the distance between AC, and the distance between BC is given by the formula modulus of y2 minus y1 as x coordinates are equal. Therefore the distance between BC is y2 minus y1. By using Pythagoras theorem, as the square of the hypotenuse equals to sum of the squares of the other two sides, so AB square is equals to x2 minus x1 whole square plus y2 minus y1 whole square. Therefore AB is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square. Yeah, now let us see, let us solve an example. So let the coordinates of 2 points A are 2 comma 3 and the point B are 3 comma 5 and we need to find the distance between these 2 points. So distance between AB is equals to AB equals to root of x2 minus x1. This is x1 and this is y1 and this is x2 and this is y2. Now x2 minus x1 whole square plus y2 minus y1 whole square. So x2 is 3 minus x1 is 2. So 3 minus 2 whole square plus y2 plus 5 and y1 plus is 3. So y minus 3 whole square. Now root of 3 minus 2 is 1 square plus 5 minus 3 is 2 square. We'll get root of 1 plus 4. The distance between AB is root 5 units. Since 5 is a prime number, we cannot reduce this one. So AB equal to root 5 units. Let me solve other example which involves negative coordinates. So let A is minus 3 comma 2 and B is minus 4 comma minus 5. And this is x1 and this is y1 and this is x2 and y2. Now what we need to find the distance between AB. So distance between AB using formula x2 minus x1 whole square plus y2 minus y1 whole square. Okay, now AB is equals to root of, in place of x2 we have minus 4 and this minus is here, and what is there in place of x1? It is minus 3. So one more minus here whole square plus in place of y2 we have minus 5 and this minus is here, in place of y1 it is 2 and this is whole square. Now what we will get? It is minus 4, minus of minus will get plus 3 whole square, and minus 5 minus 2 will get minus 7 whole square. So we'll get minus 4 plus 3 will get minus 1 whole square plus of minus 7 whole square. We'll get root of 1 square is 1 and 7 square is 49. Therefore AB is equals to root of 50. So we can't further divide this one also. Yeah, this can is. So 50 can be written as 25 into 2. So AB is equals to, and splitting the root, 25 into root 2. So AB is equals to 5 root 2 units, as both 5 and 2 are here. So the distance between AB are 5 root 2 units. if a equal to minus 3 comma 2 and b equal to minus 4 comma minus 5, here we need to observe if minus of minus 3, since x2 value is minus 4 and x1 value is minus 3, so minus, this minus is here, and x1 also have one more minus, that's why one more minus here, minus of minus will become plus, and we need to solve like this. Okay children, so this is a derivation of distance between any 2 points whose coordinates are x1 y1 and x2 y2 is given by the formula AB is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square. So what I'm expecting, so what you do means you solve the given problems. So see, 2 comma 3 4 comma 1 is the first question, and the second one is minus 3 comma 7 minus 1 comma 3. Let you take the other one, minus 2 comma minus 3 and 3 comma 2, and you need to find the distance between the given points. Find the distance between the given points. So this is take this one as homework and complete, and so we will move on to the next applications of in the next class we will have the applications of distance between any 2 points. Okay, thank you one and all.